hold on here. I've got a mirror. It wouldn't be a talk without technical difficulties, right? All right. All right, there we go. Okay. That's good. All right, so my talk doesn't have a title, because titles are dumb. This is me. I'm Mikeal Rogers. I do a few things. I have a little startup, and we make a mobile app. It's just me and this big bearded guy that you'll see around here named Max Ogden. He's great. He deals with Androids that I don't have to. And I run a little conference called NodeConf, which is sort of like this, except I wasn't able to book a brewery, so I guess you guys should be glad you're here instead of at my conference. I'm going to try to answer this question of why is Node so successful? And I guess this question sort of presumes that Node is successful, right? And so I guess that's really the first question that I have to answer is, like, is Node successful? Can you prove that it's successful? Why are you saying that Node is successful? And the answer is because fucking robots. And we have awesome fucking robots. And this word doesn't hit here like it does in the US, so I prepared this slide. So we have bloody fucking robots in Node.js, and we have all this other great value in the community. And a few things are happening that have been happening for a while in Node that this new robot stuff is just starting to illuminate. That's just starting to make it a little bit more obvious and we can observe it. So there was this awesome event in Berlin right before JSConf EU called NodeCopter. And give it up for this logo, because this is awesome. So that's a quadricopter with the hexagon around it, yeah. So Felix and a few other people are here. I believe Robin will be here by like tomorrow or the next day. And if you like what I have to say here, definitely try to make it to this event. But they did this little event before JSConf EU, and Felix has spent a bunch of time making a little library that could drive quadricopters from Node.js and could do it really, really well. And so that got everybody over the initial hump, right? And so he brings everybody into this like old pool in East Berlin, and it's got a wood floor on it. It's not like it's water. And then he hands everybody a quadricopter, and people get into teams, and everybody just starts building something. And within like 5 minutes, people are driving this thing using Node.js, right? I mean, that was like the easy part. And then people started to actually make it do things and to pull video out of the video camera. And by the end of the day, we had these insane demos, okay? So this guy, Cole, in 15 minutes was able to hook up a Wii nunchuck to an Arduino and just fly the entire robot around, right? He used this little project called Johnny 5 that I'll talk a little bit more about in a bit. Substack and Dominic Tarr wrote, so they had their copter come up, pushing to a browser using Socket.io. You could see images coming out of it on the browser that they had up. And then Substack would pull out like a red handkerchief, and then it would like see the color red, detect it, and dive at it. And then he'd yell "Toro," and it was like this whole bull thing. And you'd see like a big red dot like on the screen. It was amazing, right? And the reason that they were able to put this kind of stuff together was that, you know, like Socket.io is just part of Node, and moving data from the what? Well, it wasn't Socket.io. Okay, it's not Socket.io. All right, it's something better than Socket.io that Substack will get into later. But since everybody calls WebSockets Socket.io because they don't know any better, we're just going to continue to call it Socket.io. So I mean, like my co-founder Max worked with some PhoneGap guys, and they concurrently controlled their copter with a variety of inputs. So Max would move his phone back and forth, and that would adjust the tilt. And a guy would whistle into a microphone that went into his laptop using the Chrome audio capture API, and that would raise the height on it. And then Brian LaRue would yell commands, like voice commands, into his phone that would also command it to do things like take off and all that kind of stuff. This was just awesome, right? And they built all of this stuff in about 3 or 4 hours total, right? Like, I mean, they saw some talks, they went out to lunch, and then they just put all of these things together. And there's all of these little components in Node and all of these different pieces of value that can all be leveraged together really, really easily, more easily than I've ever seen in any other platform. If you wanted to take something that took sensor data or took hardware or worked with a copter and hook it up to like a web service, and you're trying to hook like Django to some kind of other weird Python thing, you're looking at like hundreds of lines of code to try and wire these together and lots of weird little bugs and incompatibilities. So I want to talk a bit about this library called Johnny 5. This is another awesome logo, by the way. It's named after Johnny 5, the robot from Short Circuit. If you're a child of the 80s and 90s, you'll remember the Short Circuit movies. Rick Waldron is a guy who is he's on the jQuery team, right? And so he mainly does like front-end JavaScript, and he works. He's actually on TC39 now, so he does some JavaScript language stuff. But you know, he really has his head around good APIs and what good APIs look like. But he hadn't done that much Node stuff before, and he hadn't ever worked with robots. But he just sort of like got this itch that he needed to scratch, where he wanted to build a robot. And so he started to build this robot that would sort of move back and forth and around, and then he got this crazy idea to like add a claw to it. And then he really wanted to like make it propose to his girlfriend for him. So, you know, he wrote a little command and a wrapper around all of the semantics for doing that. And at the end of the day, what he built was this amazing API called Johnny 5, and you can look it up on his GitHub. And what Johnny 5 is it's a wrapper around like dozens of little sensors and pieces of hardware. And you know, where applicable, it'll use streams and callbacks, and it feels very much like a piece of Node. But what this did was it allowed somebody oh man, I'm like blanking on names now. No good. Okay, so he's gotten more contributions than I've ever seen, right? People just send him new sensors all the time. They say like, oh, I had this other Arduino and it just needed to change this line and get it working here. But people are starting to build, you know, APIs around LCDs that look better than anybody's ever written an API to work with an LCD before. And what's more interesting to me about this example than, say, something like Express or something like Socket.io, sorry, Substack, and you know, like all of these other things that are really good in Node that are like a bit better than something that we'd have in Ruby or Python or Java, right? Like we like it a bit more, we have our reasons for that. These are APIs that have like defied high-level libraries forever. Like there's never been a really good unified API for working with this kind of sensor data. The barrier to entry for working with hardware and for working with like, you know, little Arduinos and stuff, it hasn't changed much in the last 10 years until just recently. And once we start lowering the barrier to entry low enough, we can start to get the kinds of things that we used to see on the web, right? Like the web took off not because it enabled hardcore engineers with computer science degrees to build websites. It's because it enabled people with, you know, bachelors in cognitive science to write websites and bachelors in art and high school dropouts, right? Like it amateurized this whole field, and it allowed people to really create a lot more value than could before. And this is finally happening in hardware. And this is why I think Node is actually successful, because we have all this amazing value that we can chain together, and we're starting to lower the barrier to entry for computing in general. So I think that there's three things that we did in Node that enable this to happen, right? And I'm going to talk about each of them sort of individually. This is the first one, and this is probably the most important one. This is the simple callback pattern, okay? And it's the subject of much debate and many people saying that it does or doesn't work, or it is or is not correct. But you pass a callback to something, the first thing that you get is an error. So you have to deal with the error. You have no choice. And the second thing is a result. And if there's more than one result, sometimes you'll see multiple result callbacks. But 99% of the time, it's just a single result. So for the simplest case, I want to ask a question over I/O, and I want to get back a result, we have an incredibly simple way to do that with like a simple inline function with one layer of indentation that accomplishes that task. We don't have a strange object wrapper or any kind of big API. We're not faking that it's blocking or anything like that. We have this really simple little thing. There was this great moment at like Node Summit just this, I guess, was that this year? Yeah, it's this year. Wow. It hasn't even been a year yet. I was standing there with Chris Williams, who does JSConf, and this guy came up to us and he started talking a lot, and you could tell that he hadn't really done any Node, but he'd heard a lot about Node, and he's like, well, you're doing all this Node stuff. How do you deal with like this? And Chris said, how do I deal with like convulsing my arms to the right? Like, I don't do it. I don't do that. And that's how we deal with, callback problems, is that we don't have them, right? We work around them. And if callbacks become something that needs to be managed, if we have a lot of like strange parallel and then sequential data to work with, we have libraries like async that are incredibly popular that can manage that complexity. But 90% of the time, it's simple, and we have a simple API for that. And the great thing about this pattern when you're talking about building new libraries and new abstractions on top of it is that if somebody publishes a module and it takes this function, this like simple function callback, right? But the last thing that it does is it talks to a CouchDB API, or it talks to a Redis API, or it talks to some other lower level API. It can just pass that callback on and not even really deal with it again, right? Like it can get rid of ownership for it and kind of cut its losses. If everybody did their own crazy callback pattern, then we wouldn't be able to do that. We wouldn't have that unified API. And we also get out of explaining this to people and explaining and having lots of crazy stuff in our documentation. This is a way that we're compatible between modules in Node.js without collaborating between each other. Okay, so the next thing that's awesome, it's Dominic Tarr, who you'll see later. The next thing that we have is a stream, right? And streams are still being worked on, but we built some amazing things in streams. So callbacks are great when you have a single question that you want to ask over I/O and you get back a result or an error. Streams are for things like file descriptors or sockets or HTTP servers, something where it's not one question. We're actually going to get data iteratively, or we're going to write data iteratively over time. And now we need to start handling problems like, well, what if we need to mutate the data? What if we need to parse the data as it comes out? What if we have a socket, like say we're talking to Redis or we're talking to MySQL or something, and actually we're going to be multiplexing like different commands over that and parsing them at different times. So we do have one unified interface for that in Node, and that's really important, right? Like there isn't a single unified interface for file descriptors and sockets and HTTP servers that you can build on top of, and you can write new libraries to do mutations that don't care about whether or not it's a socket or a file or an HTTP server or client. Nobody really has that. Like there's actually some stuff in Java using interfaces that can do it, but that exists inside of a Java ecosystem that is not entirely invested in that particular abstraction, right? In Node, we just have one. We have one way to do this, and we have all kinds of amazing things being built on top of it, and all kinds of amazing things being piped to each other. So this is a really important innovation, because when somebody publishes anything that works with iterative data to NPM, publish it as a stream, everybody can use it. And I can write a stream for something that I'm taking off of a file, right? I have a giant JSON object written to a file, and I need this library to parse that JSON iteratively from a file. But now somebody can use it for their HTTP responses, or they can use it for their sockets. I didn't have to do any extra work for that, right? This is how we get this is how we're compatible without cooperation and without management between these people, without all of these different developers in the community talking to each other and saying, well, how do you work with my thing? All right, so this is the Substack pattern. And this pattern is really important to the community. And one of the more interesting things about it is that the other two patterns that I've talked about, they were defined by core. Ryan, at some point in time, a few years ago, I think for both of them actually, when he ripped out promises for callbacks and later when he unified the stream interface, Ryan sort of dictated the earliest of those patterns, and we've iterated on them a bit since. This pattern has been entirely adopted in userland, right? Like somebody asked if they could make their module just a function, make the return value of their module just a simple function, and that got added to Node, and it's actually out of the CommonJS spec. It's not part of the CommonJS spec at all. And Substack, by writing hundreds of modules, really push this into the community and push this idea that a module should be so simple that it should be described as a single function. Like the default behavior of that module in all cases should be described as a single function. If not, it's probably not a single module. It's probably a couple modules, right? Like maybe you should be breaking up this task. And even when, 90% of what you're going to do with it is this one function, and then there's some other, there's other things that you might want to do that are non-default, right? You just add other properties and other methods to this return function, right? It's just an object. We can do that in JavaScript. So this is why we've never really built something like Python Sphinx or like JavaDoc, and why you don't see these huge documentation tools and projects that you see in other languages and their platforms in Node. Because module developers don't need a big documentation tool. They're writing modules that are simple enough that they can be described with a simple README. And that's really important, right? Like if we have all of these really simple modules that we can tie together really easily using these patterns, then we can treat them a lot more like how we want to treat them, which is like Legos, right? So if you read like any theoretical computer science book, or actually most books about open source and community and modules and stuff, if they ever get philosophical, they always talk about this beautiful day in the future where a programmer will sit down to accomplish a task, and they'll do almost no work. They will just take a bunch of things that people have built and put them together like Legos, right? And then they describe how their ideas are going to enable this and blah, blah, blah. And so I'm going to do the same thing. The problem with using this Lego metaphor with traditional object-oriented programming patterns is that inheritance breeds a hierarchy, right? And so one thing subclasses another thing and subclasses another thing, and what you get are these hierarchical and vertical plugin systems. And a lot of them are really feature-rich and have a lot of value in them, but at the end of the day, they're incompatible with this other guy's also hierarchical plugin system that he wrote. And then everybody has to fight about which one's is better, right? And everybody's like, I like Dojo, and I like Yui, and I like Ember, because I'm a crazy person. These are the fights that you get in because if you opt into the value of stuff that's happening in Dojo, you can't use it in Yui, right? And this is not a Lego world, right? This is not a Lego universe. Like, never did I get a fucking Lego set, a new Star Wars Lego set, and I couldn't just put those little spacemen on top, my Star Wars guys on top of my Old West Lego set. Like, they all work together. We have compatibility between them, and we have lots of little tiny components everywhere. And this is finally actually really being realized in Node, without a lot of object-oriented programming patterns, because we just have a few simple patterns that everybody follows, and we have 15,000 modules and counting of value that you can really easily leverage at any time. And so I don't think that we stumbled upon this by accident. And I also don't think that we went out of our way to do this intentionally. I think that there's something about the environment and a time and place that allows a community to finally resolve a task and finally figure something out. This project was started by Ryan Dahl, who's a very eccentric person and very opinionated about a lot of things. I want to go into a little bit of history of some other things to get to where I think that his real value came from. So there's this awesome comic book called Logic Comics. I'm not going to do like Isaac and tell you to read like a million things when you go home, but this is actually worth reading. It's very good. It's available on your iPad and your iPhone now. So it basically tracks the history of the field of logic using comic books, and predominantly it follows this guy named Bertrand Russell. And so Bertrand Russell was into logic and in the logic community at a time when they sort of stopped focusing on writing new proofs on top of basic arithmetic and started writing proofs for basic arithmetic. And the idea was that if we can prove basic arithmetic, we will have this perfect base that we can then base the entire field of logic on. And so long as we're writing proofs that just assume that the basic arithmetic is fine and that it's perfect without a proof, we're just sort of deluding ourselves and we'll never solve any of the hard problems. And so for a while, like, the field of logic was sort of like stifled their own innovation by focusing on perfecting just basic arithmetic. And so then this is an awesome story. So there's this big logic conference, right? It's like the JS Conf of logic. And this guy Gödel, I can't speak German. He, as I've found out after 2 weeks in Berlin, this guy says, "Oh, I'm going to give a talk. I proved basic arithmetic." Booyah. So everybody shows up, right? Like, it's packed to the rafters. Everybody who's anybody in logic is in this talk. And he proceeds to show his proof. And his proof, Gödel's theorem, which is very complicated and does a lot of things, but one of the things that it proves is that you cannot prove basic arithmetic. That it is actually impossible. And it's an irrefutable proof. And everyone leaves this talk incredibly depressed because they've mostly wasted their lives. And some of them still just sort of ignore him and try to keep doing it. But a lot of people sort of move on. And one person was actually sort of inspired by it. And that was Alan Turing. So Alan Turing was there when Gödel first presented his theorem. And this inspired him to stop, thinking about proving arithmetic and start just building on top of it. If we can just take basic arithmetic for granted, we might be able to build, amazing things on top of it. And this is the foundation for modern computing, right? Modern computing, and especially the Turing machine, were just logic machines, and they wouldn't have been able to have been built without assuming that the basic arithmetic behind their development just worked good enough, and then it was predictable enough. And this guy won the war and stuff. It's awesome. And that's where you can go if you can solve a problem and good enough, right? It'll never be perfect. But once you can solve it, you can just kind of forget about it, and you can now move on and build on top of it. So I want to stress solutions over problems. And in computing, because we're engineers and because we love to solve hard problems, we love to take on new hard problems, we get more invested in the problem than in the solution. And that's very problematic. I really do feel like in the last 10 or 15 years, we haven't made that much advancement in the part of computing that we all work in the software and the platform side. We've invented a lot of languages that do the same thing in slightly different opinionated ways that are slightly better than each other at one or two tasks. And that's meant that we've never gotten past it, right? C didn't change much, right? We kind of took C for granted. And C is not perfect, right? Or if you keep going even further down the stack, right? You want to try to tell me that i386 is perfect? i386 is awful, okay? Anybody that's had to deal with that level knows how bad it is. But everybody who's tried to create an alternative, clean, doesn't cooperate with it at all, they've all failed, right? We need to be able to move forward. We need to be able to take on the next set of problems. And one of the foundations of Node.js was that Ryan Dahl said, the language is a solved problem. It's not great. It's not perfect. JavaScript is anything but perfect. It has some of the worst warts of any language ever. But it's incredibly fast, and it is good enough. And one of the most important things for Ryan was that at the time, it just wasn't changing. It wasn't, the focus of the language was on making it faster and making the VM faster, and the language was not changing anymore. And that allowed us to really focus on innovating on top of it. And as Isaac put it, we also set what our high water mark was too. We're not going to care about the language of the VM, but we're also not going to go and do the Python and Ruby thing with this giant standard library, right? We're going to focus, and we're just going to do a few things incredibly well, and we're going to allow the next generation of people to be able to take our work for granted and be able to move on to the next set of hard problems. And what this has done is that it's made the Node.js community somewhat incompatible with modern institutions, especially those that work on programming, institutions like TC39 and the W3C, because institutions focus on problems, right? They form around a problem, and they want to solve it. And once an institution's like some kind of Frankenstein monster. You can't get rid of it. You can't kill it. It's unkillable, right? And regardless of how many amazing things that people do with JavaScript as is, TC39 will never stop trying to change it, right? Like that's their job forever. And we can be interested in that, but it can't be our focus, and it can't be the focus of our community if we ever want to move on. And that's sort of where I want to leave us. This is an awesome picture. Ryan's a gangster. This is also why why Node.js is great, because Ryan is a gangster. And that's my talk. Thank you, everybody.